third project was to evaluate. DEF was planning on building a sustainable city, and our job was to evaluate the financial feasibility of the following initiatives and also the environmental benefits compared to their cost as well. The two initiatives we had were efficient street lighting. So this involves basically, so the street lighting we assume is already there, and this involves adding a timing switch to the street light that turns it off, it dims the power when the facility's operation timings conclude. And that was within 2 hours of the conclusion time. So we assume the facility operation timings first, whenever it gets dark. In 2 hours within that, the power dims, and our pathways, accordingly to our pathways, the quantity, like the amount of the dimming, it increases. So the cost savings also increases. And the second initiative was automatic lighting control. So this was for indoor spaces because it involves using occupant sensors. And so we only included the facilities that had indoor spaces for this initiative. And we also added on top of this our own, so we modified the initiative a little where we considered if we spend extra money and install LED lightings instead, because we thought the OPEX would result in cost savings through electricity cost savings over the longer term. So we wanted to compare that. We compared two projects basically. One was with incandescent lighting, assumed the cheaper one, but the costlier in terms of electricity usage. And the second one was LED, but which had a costlier capex, the initial cost, but it had a lower OPEX in the longer run. And then we calculated the NPVs for both of them, and the difference was basically how much costlier the LED with the automatic occupant sensor were. The findings will be shown later.
Yeah, so our projects in brief will be focusing on environmental impact and how we can reduce it, and how we can promote sustainable practices. And yeah, we'll find solutions for a better future. Now our approach, now I haven't covered everything here, but I've given a brief picture of what we'll be doing. We will identify the number of lights and the operational hours. This will allow us to compute the baseline and after the initiatives applied energy use. Right now, within the second initiative, we have also taken into consideration the fact that there are emissions for manufacturing, transportation, and installation as well. So for these, there will be numerous carbon factors. For the mode of transport, there will be different ones, and for the material as well. And the weight and all other different required calculations were performed, right? And we found the carbon emissions and the savings. And then we also went on with capex and opex calculations. And then in the end, after we find NPV, we also get MAC. Now, additionally, we have also done one extra analysis to focus on risk. All the tools used were Excel. Our findings.
So this is the first initiative, the efficient street lighting. This is just the 90,541 is the total CO2 abated over the lifespan of the project. That's 22 years, going from 2028 to 2050. And this is the yearly breakdown of the CO2 abated. You can see it's increasing gradually because the number of street lightings, they were incremental in the projects because the build-out area, as the build-out area increased and the energy usage increased, we increased the number of street lights. And the more the street lights were, the more the CO2 abated was for switching them off. This is the...
is that cumulative or is that...
This is cumulative, the 90,500. This is the yearly abatement of CO2, assuming if we add the timing switches. I'll get to that later. This is the timing switch, the power controller we're using. This will be our capex for controlling the LEDs, the LED street lights, and these are the benefits listed. They also offer additional benefits such as centralized control, and it also helps you monitor the power. They cost about $50 each. We have them on Alibaba as well, that source are provided. So this is how the capex works. First we had to calculate the total number of street lights for every year. This is how it was. For that, what we did, because it was not explicitly mentioned how many street lights are present, so we made an estimate of the total percentage of energy use done by street lights, and we had the total energy usage data. So that was 3.5% based on this source, which says it's 2 to 5% in the user community. Then we calculated the electricity usage per street light based on the assumption they run for 12 hours and they're 100-watt LEDs, which amounted to 438 kilowatt hours per annum usage, and then we divided the percentage of total energy used by the street lights by the energy used by one street light, and that gave us the total number of streetlights at that point of time. For the capex, we basically had two costs that were initial. That was the cost of the controller, that was 185, and the installation cost, that was labor per unit, was 75. Now this got multiplied by the number of streetlights being added each year, the incremental streetlights. That's how we found our capex cost. It was 19.5 million over the span of 2028 to 2032, because 2032 is where the complete area is built out and there's no more incremental streetlights being installed. For our OPEX, we had two costs involved again. One was the maintenance and one was the cost savings in electricity by implementing the initiative. So the maintenance cost was incremental because the additional equipment we added to the streetlights that involved the timing switches and the controllers. We calculated only the maintenance cost that would increase due to that, and that you can see it's constantly increasing even after the streetlights have been built out because of the CPI escalation rate mentioned, that was 2%, and they've also been discounted to the current value with the WACC. This is the energy use. As you can see, the total energy used without the initiative would have been this much, and after implementing the timing switches and the dimming, it's this much. The gap increases more and more because as the number increases, the savings increase, and as the pathways change, our dimming intensity changes. So we dim them more in the future pathways. This is the energy saved. As you can see, this is also trending upwards with the pathway. Every sudden jump you see is the pathway. This is the first 35% dimming, this is 40% dimming, this is 50% dimming. And this is the cost of the electricity saved per year. This was our cost savings in our OPEX, and this was also been discounted to the present value to calculate the net OPEX cost, which was the net OPEX savings was 16.7 million. If we hadn't used those switches, we would have spent this much more on using conventional lights that stayed on without dimming throughout the dark hours. So the difference between our capex and opex gave us the NPV, which was minus 8.6 million, and the total the tons of CO2 abated was 90,541. So the cost came out to 30.44 real per ton of CO2 abated. That was for initiative 1. Initiative 2.
So our second initiative, as mentioned earlier, will be focusing on interior lighting. Now, ALC lighting has been equipped with various features, but we have also decided to implement LED lights as well. So this will require us for a complete swap. So for baseline energy use, we didn't use the data provided in the baseline input tab. We have, through references, assumed a value between a range, because various references are giving a range, and we assumed a value to calculate the baseline energy use, and the same for the after initiative 1 as well. Now, once we do that, we get the abatement, and we have done this zone by zone as well, and then we have found the total. As you can see in the graph, the first 3 years is basically where the lights are being built. So these were the years, I believe, 28, 29, and 30. The years before that, there was nothing. And also in the first pathway, there was no energy use for the first 3 zones because due to construction and stuff like that. So for the first 3 zones, amphitheater, cinematic arts complex, and global sports tower, the energy use starts from 2030, and for the last zone, it starts from 2031. So that's why the pathway 1 was basically of no use for us, and from pathway 2 onwards is where we take into consideration the energy use. Now, since you also have dimming effect, the percentages were 70% for this pathway. And for the last pathway, it is basically it turns completely off. So when there's no occupants, it turns off, and this explains why the abatement increases. Left capex.
So for the calculation of the net capex cost or saving, we compare 2 projects. So one is of the normal lighting and one is of the ALC lighting. So the capex for ALC lighting cost around 342,000 Saudi riyals, and that for the ALC lighting costed around 1 million to 1.2 million Saudi riyals. So this made us incur a net capex cost of around 867,000 Saudi riyals. we incurred a cost because the cost of setting up one AAC light is quite higher than setting up a normal normal light. As you can see, the lighting control system, which contributes to around 41% of the cost for setting up a AAC light. This component is quite expensive because it controls the energy usage and controls when the light will turn on or off or even dim. Next up is the energy usage of AAC lighting. For pathway 2, we found out that one AAC light uses around 123 kilowatt hour of energy annually, and for pathway 3, one AAC light consumes around 85 kilowatt hour of energy. In pathway 3, we are completely reducing the energy use whenever the light is not on. Whenever there is no motion detected, the light completely turns off. So based on that energy use, we calculated the OPEX, and the OPEX for normal lighting was around 1.8 million, while that for OPEX of the AAC lighting was around 1.4 million. So over here we are having a OPEX saving of around 800,000. As you can see in the OPEX projections line graph, the value of the normal lighting is going down over the years. This is because of the discount factor, but it is still more expensive than the AAC lighting. Also, we found that the net difference in net present value was around minus 28,000. So despite this NPV being negative, it is still viable because if we expand the project over over the horizon, so suppose till 2080 or something, we will be making more savings, and that will make it a viable investment.
Now for Mac, as my colleague mentioned earlier, we have found the difference between NPVs, the one without the initiative and one after. We divide this by the total abatement calculated. This will give us our Mac. It's negative, but it's not too much, and it's manageable as compared to the previous initiative, which requires heavy subsidies, carbon credits, and tax breaks maybe. This one is manageable and not that bad. So it takes so basically for each ton of carbon emitted, we will be spending one. So the risk analysis by Yash.
Right. So I'll be discussing about the risk analysis. So risk analysis is it's a sustainable initiative. So every project comes with a risk, and identifying them early helps in preventing delays or failures. So let's identify the risk first. So first of all, we got financial risk. It has high cost of implications. Then we got operational risk. In operational risk, delay may be caused due to shortage of raw material, or disruption in chain of supply. Then we got technical risk. In technical risk, inaccurate data modeling could lead to poor decision making. Then we got environmental risk, and so some factor may affect the environment, which is unintentionally done. And then we got stakeholder risk. In stakeholder risk, resistance from developers, investors, or public due to cost or feasibility concerns. Then let's prioritize this risk. In high priority risk, we got operational risk, financial risk, and technical risk. These can be significantly affect the project success and required immediate action. Then we got medium priority risk. In medium priority risk, we got regulatory and stakeholder risk. This needs continuous monitoring and management. Then we got low priority risk. In low priority risk comes environmental risk. Though less likely, they must be periodically reviewed.
As appendix, which mentions the assumptions based on the initiative. Yeah.
For sources I mentioned separately.
Yes, and we also have for the second initiative as well. Continue. And this is our team. Thank you to Professor Wade and our tutor for being a great help along the way. And yeah. Questions?
Thanks very much, guys. I do really appreciate, well, the what we call the live presentation. So
I think it calls for a bonus point.
okay. So, but well done. I think it was very well laid out, well structured, logical as well. It was straightforward to follow. But although that said, I had a couple of questions on your I think assumptions in terms of the lighting first initiative. So you said there was a 50% reduction for lighting features, the outdoor lighting, but I wasn't sure 50% reduction of what? Like reduction in operating time, or like
Power usage. So we assume that the facilities operate from. Wait, let me show you the assumptions. So can I open the Excel? Okay. I can open it. Yeah. Where is it?
can you also just explain
How many groups do we have? Last one, yeah? Last one.
Three.
Three more?
Yeah, 1, 2, and 3.
No, we probably have one more. Yeah?
This one.
We said we were finishing at 6, maybe you guys came late.
Right,
Because we
so
were
it's
running late. We said we finished at 6, yeah? We are finishing at 6. Sherry, can you explain to them, please?
yeah, well, maybe one more.
We can do one more, okay? Discuss with them, Sherry. Please explain to them what's going on.
The facility.
Wait. Discuss with
No, I just want to, yeah, so on the first slide where you said there was a, you assumed a 50% reduction from
Otherwise, there's problem.
on the very first slide.
Okay.
I think it was the executive summary.
No, don't change it. No. Do you know it again? Okay. Okay. I'm not good at technology. It's something.
So we assumed the facility operation, the lighting, street light operation hours to be 6 p.m. to 6 a.m. So these are the dark hours, and the facility operations will conclude at 11. And we've planned on dimming the lights after 1 hour of the facility operation, so people can walk back home, or if they're still outside or talking or ending conversations or whatever. So we've kept the lights operating at full capacity from 6 p.m. to 12 p.m. That's 1 hour after the facility operations conclude. After that, according to the pathway, we reduce the power consumption of the light.
By
Street lights.
50%.
By 50% in the last pathway.
Okay, after 12 a.m.
After 12 a.m. to 6 a.m.
After
For 6 hours.
Okay. Okay, understood. So, okay, that's what I was trying to understand. Okay, so it's basically dim the light after 12 for about 6 hours.
Exactly.
And that's where the
energy
savings
savings.
are. Okay. And so, and how then? But when I was looking at your OPEX, right? There's a slide on the OPEX. I think there you mentioned that the OPEX was calculated on 12 hours operating basis, but I think it's more than 12 hours. Right?
That was for initiative 2.
Two, I think it was one. Okay, maybe it was.
For one, it's just this. The timings mentioned above, 6 p.m. to 6 a.m. But the reduced power hours to 12 a.m. to 6 a.m.
Okay, and then so in terms of the OPEX, is it purely energy that you are being estimating?
So OPEX, we have. This is our OPEX. So we have the cost of electricity saved. That's our OPEX savings, and then the incremental maintenance cost because of the addition of the timing control units and the power control units. And this has been increased according to the CPI as well. And it has been discounted as well over here with the VAT discount factor. their maintenance costs have been increased according to the same year.
Okay, so it's not okay. Understood. So OPEX basically because of two things, right? Two things. We savings and plus additional costs on maintenance. Okay. And what was your for the NPV? I was trying to understand the duration of your evaluation.
It was 22 years. So we found this is the present value of the OPEX total, and this is the sum of it.
22, and why 22?
So it was 2028 is when the facilities, there's power consumption in the facility. So before that, in the baseline data, there was no energy usage before 2028. So we assumed that obviously the street lights were not operational. And after 2028, when there was power usage, then we started assuming that street lights got installed.
No, that I understand. I was just, I guess my question was also, because the second initiative has a negative NPV, right? And you said, if you extend eventually the evaluation period, it might go positive. So I was trying to understand why did you, so 22 years for both, or?
22 for both, but the second project, what we basically did is we did not calculate the NPV for one project. It was two projects we proposed. One was with the cheaper lighting but more energy usage, so that's where the cost increased. And the second alternative was more expensive LED lights, but they would have a less cost of electricity over the 22 years. But what we found out, even in 22 years, the NPV of the project with the LED lightings was still more because it had a higher capex, and the OPEX in 22 years, OPEX savings could not displace that cost. But if we were saying if we expand the horizon from 22 years to let's say 30 or 40 years, the OPEX savings in the LED project will definitely offset the extra capex costs.
But why 22? It's a very
Because
precise. It's not like 10, 15. It's 20.
So we only took it to 2050, and
and your start is 2028.
2028. Yeah. So it happened to be around.
So that's.
On your, can you go back to the slide there, please? You said that, maybe I didn't quite understand it, but your NPV was positive. Keep going. It was the sorry. Go back. Yeah, this one. So sorry, go back to that one.
So this is just the comparison of the capex.
So you're saying it's a decrease. Okay. I think there was another one where I saw the net present value was negative, and then there's another positive number, and it just
This?
to me.
This is the NPV, that's for the street lighting, and this is the CO2 rate.
No, it's different. It's it doesn't have the numbers on, so I can't tell you which slide it is.
This one. This has a saving.
Yes. Okay. So you're telling me, yes, this is it. So I've got my two lightings, and there's OPEX saving, which is 800,000, and then that relates to a negative NPV.
So the NPV calculations actually, what we did is this is done in Excel. I can show it to you.
Just talk about it.
Okay, I'll tell you about it. So on top, the saving is just comparing the OPEX to OPEX.
Okay.
For the NPV, difference in NPV, we had to calculate the NPVs for both the projects. That involved doing, so there was CAPEX, that was 342 for normal lighting,
Okay.
plus the OPEX for normal lighting. The sum of that was the NPV. It was a negative number because there's no cash inflow.
So capex is bringing the NPV down.
CAPEX is bringing the NPV for
paying for itself, I guess, in 22 years.
Yeah.
These are OPEX total or annual?
This is the total OPEX discounted by the present value for the ALC lighting. So if you combine these two, let's say the CAPEX normal lighting and the OPEX normal lighting, this is the NPV for your normal lighting project, and then for the ALC lighting, you combine the CAPEX.
6, 7, and the other one is 8. 8.
So you combine this and then you subtract the NPVs of both the project, that's when you get the difference. Basically what we found out was the NPV of the ALC lighting project was more, it was costlier than the normal lighting.
Okay.
That's why we had a negative difference.
Okay.
So it was costly to implement the project over the 22-year horizon. But longer than that, we will save more in OPEX, and the difference between the OPEX of ALC and the normal lighting will increase, giving us a positive difference.
Yeah, interesting. So kind of LED lighting is not very cost effective.
Yeah, well, that's what I was trying to scrutinize.
But maybe it's the
I
an assumption of electricity. Did it keep it constant, or there is a bit of escalation?
Also, it's not just the electricity cost; it's also the dimming. So our initiative involved adding occupant sensors as well. So we assumed 50% occupancy rates in the facility, and according to that, the pathway. If there was no occupant, the dimming level varied according to the pathway. First it was 70, then 100, and then 100.
Yeah, I mean, whatever, I mean, that capex, that includes both dimming and LEDs. This is.
Yeah, capex includes
Okay,
LED.
yeah, but I will just, but the OPEX savings, obviously that's, most of it is electricity.
Electricity, yes.
And, so did you assume kind of a constant electricity rate around 22 years, or?
No, we calculated the OPEX for the different pathways. So like the first pathway was 50% reduction, second pathway was
No, my question is really assumption of electricity cost.
yeah, you can see over here the OPEX for ALC, right? For the first pathway it's 44.76 real. For the next one is 44.73.
But it's a constant for the 23 years, right?
So the electricity
It's the same
usage
price.
after the energy usage started, it was constant. Everything was built on.
But was the price, because 400 SAR today is not the same as 400 SAR tomorrow, and if we're discounting the net present value,
For initiative 2, I don't think we did not implement the CPI escalation, but for initiative 1 we've done that.
okay, cool.
No, but yeah, it's okay, it's an assumption being made, it's fine, it's negative, it's okay. Okay,
Overall, I thought it was really good. It's not hard to, it's not easy to do what you guys did, so well done. And I thought the responses were really good as well. Well thought out, well communicated. Bravo.
Thank you. We get the final word. Okay, let's see.